break, I am back, and today we are going to discuss this Leetcode problem, regions cut by slashes. So, first of all, don't confuse with this medium tag. This question is not medium. This is definitely a hard problem because this requires too much visualization. So, first of all, let's discuss the prerequisites for this problem. First of all, you should be aware of connected components in a graph, how to calculate the number of connected components and how to play with the connected components of a graph. Secondly, you should be aware of the problem number of Iceland, which is also a Leetcode problem. I guess this problem is very much inspired from that problem only. So let's quickly discuss about number of Iceland problem first. So in that problem, we are given a grid where each cell is 0 or 1, and we have to compute the number of connected components. Uh, Basically, where I guess 0 was representing empty cell, and 1 was representing the land, I guess. And we have to yeah, and we have to compute the number of Icelands. So for that we used BFS or DFS traversal. Basically, in that question, we we used a particular cell x comma y of that particular matrix as a node of a graph. Basically, we used that this cell is connected with this cell by this edge. Similarly, this, then this, and this, if these are ones, right? Similarly, when we are at this one, we started our DFS traversal like this. We go to this cell. After that, we went to this cell, return to this, went to this cell, then this, and then this. So basically, this is uh, this is the way we represent a matrix as a graph, where the node of a graph is not a single number; it's a cell represented by x comma y, right? So I will use this concept in this problem also. So first of all, let's read this particular problem. In this problem, we are given a n cross n grid. Okay, so n cross n grid is something like this. N cross n. You all know what n cross n grid is, and it is composed of 1 cross 1 squares. Basically, these small squares. It is talking about this type of square, 1 cross 1. Okay, and where each 1 cross 1 square consists of a forward slash or a backward slash or a blank space. Okay, these characters divide the square into contiguous regions. Okay, given that grid is represented as a string array, return the number of regions. Okay, backslash is a escape sequence, we all know. So to represent backslash, we write double backslash, as we all know in C++. Okay, so first of all, let's understand from test cases. I have already drawn this the visualization of all these given test cases. So in this test case, the grid was 2 cross 2, right? So I represented this 2 cross 2 grid as like this. So in the first row, the first cell was blank, as you all can see, and then the second cell, that is 0 comma 1, it is containing the forward slash. I have created forward slash. Then in second row, the first cell is having forward slash, okay, and the second cell is having empty cell, okay. Okay, so after writing these forward and backward slash, we can see that both of these forward slashes collectively dividing this whole grid in two parts, where first part is this and second part is this, two regions, right, which is the output also. So let's understand the second test case. In this test case, we are again we are having 2 cross 2 grid, and in first row, the first cell is empty, okay. Second cell is having forward slash, okay. Second row, both of the cells are empty. Okay, so you can see that this particular forward slash is not even dividing this grid into some partitions, because initially it was one region, and again after this forward slash also it is one region only. So the answer is one, right? So let's go to this test case, in which in first row again we have 2 cross 2 grid. In first row we have first forward slash, then backslash. In second row we have first backslash and then forward slash, right? We can see that in this test case we have divided our grid in 5 parts: 1, 2, 3, and this is the fifth part, right? So 5 is down. So let's see how to formulate this problem. So first of all, in this problem, it's difficult to figure out that this is a graph problem. So let's first of all visualize one particular cell. A particular cell, uh, like 1 cross 1 cell. In this particular cell, a forward slash can occur, a backward slash can occur. You can see that a particular cell you can divide, like, if there is forward slash, these are the two sections. If there is backward slash, these are the sections. But basically, uh, smaller scale, we can say that we have divided our particular cell in four particular triangles, like this. I have numbered these triangles as 0, 1, 2, 3, just for notation. You can use another notation also. So this is how a cell is dividing in this problem. So if I say how I can visualize a graph in this particular grid, let's say I have again 2 cross 2 grid. I have divided all the cells in four triangular regions. So if there is no diagonal, that is a forward slash or a backward slash, I'm saying about this. If there is no forward slash or if there is no backward slash, all these triangular regions are connected to each other and creating a graph like this. Also, this particular triangle is also connected to the uh, opposite triangle of adjacent cell. Again, basically this type of graph is occurring if we don't have any kind of diagonal, right? So first of all, let's observe some things. First observation which I made in this problem is, uh, no matter if there is diagonal like this or this, you can see that these edges are not affected. These edges are edges with adjacent cells triangle, right? So let's understand. Basically, if I am having this particular cell in which there are four triangular regions, right? Uh, let's number these triangular regions 0, 1, 2, 3, right? So I am also having some like four cells adjacent to this particular cell, and these particular cells are also having these triangular regions. Let's quickly draw these. Let me first connect my laptop to a charger. Bring out the battery. Yeah, I'm back. So let's quickly draw all these triangular regions. So yeah. No matter if I am having diagonal like this or this, these particular type of edges are still there, right? You can see triangular region 1 is connected to triangular region 2 of upward cell, and triangular region 1 is connected to right, like the triangular region 3 of right cell. Triangular region 2 of a particular cell is connected to triangular region 0 of downward cell, lower cell basically, and the triangular region 3 of particular cell is connected to triangular region 1 of left cell, right? So this is how, if there is no diagonal, the edges with adjacent cells are occurring, no matter I am having diagonal or not. So now let's consider those edges which are present inside a particular cell, right? Triangle regions again. So 0. So let's first consider, uh, if I'm not having any kind of diagonal, already I know that all these triangles are connected to each other, right? Like this, to adjacent basically. This is how these are connected if there is no diagonal. Let's now consider if there is not a there is no diagonal of this type. If this forward slash is not occurring, that means, if it is not occurring, that means 1 is connected to 0, 2 is connected to 3, because at this particular time I just know that this is not occurring, but this can occur. That's why I'm not saying that. I'm not saying anything about the connection between 0 and 3 and 1 and 2, right? So let's again repeat this thing. If I'm not having this kind of diagonal, that means 0 is connected to 1, because 0 and 1 are adjacent, and again 2 and 3 are connected, right? Okay. Again, if I say if I am not having this kind of a diagonal, that backward slash, at this particular time have no information whether I am having this diagonal or not. Just know that I don't have this kind of a diagonal, right? That means 0 is connected to 3 and 1 is connected to 2. So this is how the diagonals are affecting the edges within a cell. So let's now create an algorithm to solve this problem, right? So first of all, what I have to do is, I also uh, after all these edges, I just have to uh, calculate the connected components, right? As I can see like this. If I say, if I do dry run on this test case, right? So let's just analyze edges in this particular graph. This basically there is no diagonal in this particular cell, so all these are connected to each other, right? This is already connected to this. This is connected to this. This is connected to this, because this diagonal is restricting these and this to connect, right? Again, this is connected to this is also connected to this and this, right? You can easily see that this is a one component which is occurring, and this is a one particular component. So what we have to do is just calculate number of connected component, right? Number of connected component in a graph. I have changed the particular problem from grid to calculate the number of connected components in a graph, where each node is represented by its row, column, or its type, where type is basically type of triangle, 0, 1, 2, or 3, right? Row can be from 0 to minus 1, and column can be from 0 to m minus 1, right? So this is how I represented one particular node using row, column and type of the particular triangle. Yeah. So let's now formulate a algorithm first. Uh, Basically what I have to do is I have to iterate for each triangle of each cell, simply as we always do in case of connected components. If this particular node is not visited, right? Called DFS or BFS, but I would like to use DFS in this problem at that particular node and increment the count of connected components, right? And after all this thing, just return the count. This is the basic format of this problem. So after all this understanding, let's go to the coding part. I have already coded this up. So first of all, these are just macros. I have stored number of rows in n and number of columns in m. In count, I will store the number of connected components, or you can say the number of regions. This is just a visited vector, three-dimensional visited vector, n cross m cross 4. 4 is for 4, as we have 4 different types of triangles, right? I have implemented a lambda type of DFS function. You can also implement outside the function, but I implemented lambda function to just to remove the additional parameters. This is just a simple DFS implementation. First of all, I have just this if is just pruning. It is checking whether the particular cell is valid or not. If row is outside, basically if row is less than 0 or row is greater than equal to n, or column is less than 0 or column is greater than equal to m, or whether or the particular cell is already visited, just don't go there and just return. First of all, I have marked visited that particular node. So I don't have adjacency list. I have to go to the adjacent nodes. So I have to check. First of all, I am considering the edges with adjacent cells, right? So let's again see. If the cell was of, if the triangle was of type 0, this edge is occurring. So I am going from particular row comma column comma type 2, row minus 1 because I am going upwards, column is same, and type is changing from 0 to 2. Yeah, row is decremented, column is still same, and type is changed from 0 to 2. Basically I am considering a upward edge, right? Else if the type of a triangle was 1, if a type of a triangle was 1, I am considering this edge with triangle 3 of right cell. Basically this is right cell, that means row is still same and column is incremented and type is now 3. I have called the DFS to this cell, this particular node. This I am considering rightward edge. Similarly for type 2 and type 3, I am considering this edge and this edge. For this edge, type is changing from 2 to 0 and row is changing from row to row plus 1. Column is still same. For this particular edge, column is changing from column to column minus 1 and row is still same. Type is changing from 3 to 1, right? So after all these, because all these edges are not affecting by any kind of diagonal, so these are still same in every case. So let's now consider edges within a cell, right? As I have already mentioned, if particular cell is not containing a forward slash, if there is no forward slash, that means 0 is connected to 1 and 2 is connected to 3. Now I have observed a bit manipulation observation in both these pairs. Let's see what 0 is. 0 is basically 0 0, 1 is 0 1, right? If I do 0 XOR 1, I get 1. If I do 1 XOR 0, 1 XOR 1, I get 0. Basically if I want to change from interchange 1 to 0, 0 to 1. I just have to XOR this thing with 1. This is what I did. As we are considering, similar thing happens in case of uh, I'm considering this forward slash, right? So if there is no forward slash, then edge will be between 0 and 1 and 2 and 3. I have already discussed how I can interchange the 0 1 pair. So now, let's now discuss how we can interchange 2 and 3 pair. So 2 in binary representation is just 1 0 and 3 is 1. You can also you can directly say that if I take XOR of 2 with 1, I get 3, right? Yes, and if I do XOR of 3 with 1, I get 2. So basically this behavior is similar in this in 2 and 3 pair also. So I can interchange 2 3, 2 to 3 and 3 to 2 using this same XOR thing which I did in this case only. So let's now consider if there is no backward slash, right? So if there is no backward slash, that means 0 is connected to 3 and 1 is connected to 2. Okay, so basically now I have to interchange in between 0 and 3, 1 and 2. Let's just see the behavior of 0 with 3 and 1 with 2, right? So uh, if I do what I can do, yeah, if I take XOR of 0 with 3 or 3 with 3, I can see that 0 XOR 3 is 3 and 3 XOR 3 is 0. So if I take XOR with 3, I can interchange 0 to 3 and 3 to 0. And in this case also, if I take 1 XOR 3, I will get 2. And if I take 2 XOR 3, I will get 1. So basically if I have to interchange in between 0 and 3 or in between 1 and 2, I have to take XOR with 3, right? This is what I did in this if case. If grid of row comma column is not backward slash, I have used double backslash because backslash is an escape character. So to reprint this backslash only, I have to write two backslashes. So then I called DFS of row column and type is XORed with 3. Here in both these cases, row and column is same because we are considering edges within a same cell. Within a same cell, row and column will not get affect. So this is just a simple uh, yeah. This is just calculation of connected components. I have iterated from each row to for each row, column, and type. If this particular node is not visited, I just called the DFS function and incremented the count of connected component and just returned the count. Let's just run this code. Uh, it is working for these sample cases. Let's now submit this code. So yeah, it got accepted. I think this video would be helpful for you. Thanks for watching. Bye.